How we doing out there? This is Anthony, and today I want to go over two quick objectives: writing quadratic equations to model area problems, and then solving those resulting quadratic equations in context, right? In the context of these area problems. And so, essentially, two different problem types. One that I'm calling a simple area problem, where there is no addition or subtraction of areas, and then one where I'm referring to it as a complex area problem. That in this case does involve subtraction. So let's get into it. As seen in the diagram, Vanny is building a walkway with a width of X feet, go around a swimming pool, etc. So yeah, 16 times 10, we know this inner rectangle, the area of the pool, is 160 square feet. Okay, but we're talking about if the total area of the pool and the walkway, that's important. So this entire area, the pool and the walkway, that's what's equal to 832 square feet. We don't need to know this 160 feet squared. It's really not relevant because what we're talking about here is just the outer rectangle, which has its own base and its own height. Now, please, a common mistake here is to say, well, the base of the pool is 16 feet and we want to add on the walkway, so we're going to x plus 16. That is a common mistake, right? There's an x on each side. We're extending it x feet to the left and x feet to the right. So 2x plus 16 will be the base. And similarly, not x plus 10, but x on the bottom and on the top, 2x plus 10. Alright, using our area formula, because this is a rectangle, area equals base times height. Total area, 832, is equal to our base, 2x plus 16, times our height, 2x plus 10. So here we go, 832 equals 2x times 2x, 4x squared, 2x times 10 is 20x, plus 32x, we get 52x, plus 160. Alright, we wrote our quadratic equation to model this area problem, and now we have to solve it. How do we solve quadratic equations? Let's get everything equal to 0. In this case, by subtracting 832. Alright, and we'll have, essentially, and kind of using the reflexive property or symmetric property and moving everything over to the left-hand side, as I'm accustomed to doing. This will be, what is that, negative, subtract 200, add 40, negative 672 if I'm not mistaken. Alright, equals 0. From there, it's up to you how to solve this quadratic equation. You might try to factor, you might try to complete the square, or use the quadratic formula. In factoring, we usually look for a greatest common factor, and so I think we see that all three of these terms are divisible by 4. So we can go ahead and divide both sides of our equation by 4. Right? If it were factoring, we'd have to hold on to that GCF. So dividing by 4, we get x squared plus 13 times x minus 168 is equal to 0. Now from here, if you can factor it quickly, go for it. I really can't. I don't know the multiples of 168, negative 168, that add to 13. Oh man, I wish I did. I'm going to kick myself for it in a second, I'm sure, but I'm going to use the quadratic formula. X equals, oh my goodness, the opposite of b, plus minus the square root of b squared minus 4ac all over 2a. So I will get x equals the opposite of 13 plus minus the square root of b squared minus 4. A is 1, c is negative 168. Cool part about multiplying by 4 is, I just divided by 4, so I know that it's going to be 672. Negative 13 plus minus the square root of 169 plus 672 all over 2. So we get x equals negative 13 plus minus the square root of, 841 divided by 2. That's going to be 29. X equals negative 13. I'm only worried about the plus 29, because if I subtract 29, 13 minus 29, I'm going to get a negative number. We can't have a negative width for a walkway, so I'm just going to stick with the positive. Alright, x equals negative 13 plus 29 is 16 divided by 2. I get x equals 8. So the width of the walkway is 8 feet. Boom. Done. Alright, there's your picture. Check your base, check your height. Use the area formula, area equals base times height. That's our quadratic equation, and then it's up to us to figure out how to solve it. In this case, dividing by 4 worked really well. Might not work all the time, but there you have it. Now, solving I guess it should work all the time, right? Number theory, folks, or, yeah, number theory, folks. Maybe because of the 2x and the 2x. I don't know. Does there have to be any relationship between the 10 and the 16? Do they both have to be even in order for, right? Because I can factor out a 2 here, because I can factor out a 2 here. I wonder, will it, yeah. Anyway, neither here nor there. Because I think it happens in this problem again, too. But anyway, this one, neither here nor there. Really, don't worry about that, especially if you're a student going through this stuff for the first time. Same deal, 2x plus 9, then the base of it, right, will be 2x plus 20. Same deal, work with your area formula, base times height. Yes, 20 times 9 is 180 feet squared, but we're not worried about it because the total area of the pool and the walkway, right, you don't have to separate out that 180, but go through that same process with practice 1 here. Once you've completed the problem, check the answer key that I've shared. Make sure your solution is the correct one. Same for practice 2. Alright, determine an expression for your base, an expression for your height, total area of the pool and the walkway, 650 square feet. Get your solution, check the answer key, make sure it's the correct one. And now, example 2, solving a complex area problem. It's the same picture with an outer rectangle and an inner rectangle. Alright, however, it's complex, so it should involve some addition, some subtraction, but we'll read this. Right, so the pool, 20 feet by 40 feet. X on all 4 sides. 40 times 20, what is that? 800 square feet. Okay. She has enough seed to cover 700 feet squared. That is not, right, the area of the pool and the strip of grass. That should just be the strip of grass. That's the only area that we want. Right? We don't want to throw seed in the pool. So in this particular problem, the area that we're in question here, we have to do the outer minus the inner. Alright, and that's what's going to equal this 700 square feet that this gardener has enough seed to cover. So the outer, I think, starts out the same way. Alright, a lot of the same mechanics here. 2x plus 40, and then our height, 2x plus 20. Our outer, again, it's a rectangle, so base times height, our 2x plus 40 times our 2x plus 20 minus the inner, that's our 800. Alright, 2x times 2x, 4x squared, 2x times 20, 40x, I'm not going to show all that work, 40 times 2x, 80x, so 120x, 40 times 20, another 800, minus 800 equals 700. Alright, there's the resulting quadratic equation to model this area problem. Now it's up to us to solve it. These 800s reduce. 4 times x squared plus 120x cancel each other out, reduce to 0. 800 minus 800, good, equals 700. Let's subtract 700 from both sides. So we get 4 times x squared plus 120x minus 700 equals 0. And here we go. It happens once again where we can divide by 4. X squared plus 30x minus, I guess that's going to be 28, if I'm not mistaken, equals 0. We'll multiply to 28, negative 28. adds to 30. Man, why can't I think of any of this stuff today? And that's not right. 28. 28 divided by 4. 25 times 7. Where am I getting 28 from? I was doing divided by 25, but it's divided by 4. So 4 goes into 125 times. 25 times 7 gives us 175. Or dividing by 4, 700 divided by 2 is 350. 350 divided by 2, 175. My goodness. Now, what multiplies negative 175 adds to 30? If you know those, great. If not, I guess we're doing the quadratic formula. I could do both because I know it's 35 and 5 if I'm not mistaken, right? So I know that this will factor to x plus 35 x minus 5 equals 0. Double check that. 35 times 2 is 70. 70 times 2, or 35 times 4, is 140. Yeah, so that does work. So my two solutions, right, if I then set each one of these equal to 0, I get x equals negative 35, x equals positive 5. Well, can't have the negative, so the width of our walkway will be simply 5 feet. All right. I guess if you needed to, right, the other way to solve this quadratic equation, if you need the support here, right, would be to go to that quadratic formula using a is 1, b is 30, and c is negative 175. Right, we'll get x equals the opposite of b, negative 30, plus minus the square root of 30 squared minus 4, a is 1, c is negative 175, all over 2, negative 30 plus minus the square root of, that's going to be 900, plus 700, all over 2. So we'll have x equals negative 30 plus minus the square root of 900 plus 700, 1,600. That's a good perfect square. That is 40. So x equals negative 30 plus 40. I dropped the minus because, again, negative 30 minus 40 would just give us a negative. We can't have the negative width for a walkway. 10 divided by 2, and we get x equals 5. Either way, whether you were able to factor or had to resort to the quadratic formula, you get a walkway width of 5 feet. So here I just have one problem for you to practice. Again, should be that same setup, outer rectangle, inner rectangle. The outer rectangle, what's the base, what's the height? Write your equation to model this particular complex area problem, and then solve whether through factoring, completing the square, or quadratic formula. Check the answer key and make sure your solution's correct. But that's it for me. Thanks for watching, and good luck.